Here's the Balluff BSP 00Z3. So it'll does a -1 to 10 bar vacuum pressure. It also has 2 outputs, and it's an IO-Link device as well. So this is the device we'll be looking at in the video, and I have it talking to a IO-Link master right now, so I can configure it. We'll see the configuration tool as well. We can do it with push buttons on the face. We're able to change the values through these buttons. Just makes it easier with IO-Link Master. And this is just like a pump bulb that you find on a boat or something. So on this end, it's gonna get a vacuum, and this end it gets some pressure. And it'll hook it to this, and it does leak off a little bit quicker than I like, so I need to tape this connection fitting to slow down the leakage. Okay, you can get a good look at the face of this Balluff vacuum and pressure device. You can see that it has an IO-Link indicator, which is flashing, so it's talking IO-Link, and it has 2 outputs. Right now they're both made. I'll explain why. And it's in a PSI. You can choose a unit to PSI. So it's right now it's showing that it's a vacuum of -0.02 or 3. It's kind of jumping back and forth and PSI. And what we want to do is we're going to simulate it. So have a vacuum bulb here, and we want the output 2 to come on if it's below closer to atmosphere. So not a good vacuum. We want output 2 to turn on, which it is. And we want output 1 to control the vacuum pump. So I'm going to squeeze this vacuum ball. Output 2 went off. So now it would simulate the vacuum pump running output 1. And as it gets a better vacuum, the pump will turn off. So we have a good vacuum, -2, and it'll turn back on if it gets below a certain point. We'll look at the set point shortly, and if it gets down near atmosphere. So this output 1 would be controlling the vacuum pump and turn it on and off. And then if it ever did go to atmosphere, output 2 would be an alarm, turn an alarm on and let us know that we had a problem. So I'll show you how this is configured with the IO-Link Master. I think I have everything on the same screen, so now you can see the outputs 1 and outputs 2 are actually on right now. So it would be, output 1 would be telling the vacuum pump to turn on, output 2 would be telling us we have a problem. So I'm going to induce a little bit of vacuum. So output 2 went off. It knows that we have a certain level of vacuum, and we hadn't attained the full vacuum. I hit it again. So if we get a full vacuum, output 1 goes off, so the vacuum pump would turn off momentarily and then turn back on to try to maintain the vacuum. And then if I can squeeze this here, you'll see when I squeeze it, it's kind of all happening a little too fast. You can see the actual value changing. So this value is here is what's the IO-Link device seeing. So if I create the vacuum to the high scale, and if I scroll down, you can see our points here. We're saying keep the vacuum on to -16 and then turn it off and let it come down. It hits -8, turn back on, pull the vacuum back down to -16, turn off to -8. And then if you come on down into this scale, if you get to -5, you're going to gauge the second set point, the second set of contacts, which is how you have a warning. So it's right now, I'll go back to it and we'll see if I can just get a little bit of vacuum. So output 2 turned off, and I'm gonna have to squeeze this bulb again. So it's gonna momentarily turn 2 back on. Now I have a squeeze the bulb further. I should get a higher vacuum, which should make it to where the vacuum pump turns off, which is what happened with output 1 turned off. And as it loses vacuum, it turns back on. So it's just all happening a little quick because I only have this small bulb to create a vacuum with. And you can kind of see, it's kind of interesting to see the IO-Link interface. You can see IO-Link in real time here as I mess with the values. You can see the pressure value change. Okay, here's the information from the BSP technical data sheet. So it's this is the device, the -1 to 10 bar, the BSP device that we have. So it's saying the range that we'll see on the outlink values are going to be minus 100 to 1,000 with this multiplier. So I made a kind of a cheat sheet over here. There's the range, minus 1 to 10 bar is the same as minus 100 to 1,000. And just talking about PSI, or if you're thinking PSI, it's basically minus 14.5 PSI to 145 PSI. So we know if we're wanting to see what outlink value number we would get out of a pressure. If I put in 14.5 PSI pressure into that sensor, I should see a 100 for a value on the as the outlink value, or minus 14.5 PSI be minus 100 to be down on this scale. So if I wanted to if I had a value that came across an outlink and I wanted to know what 25 was, it would be around 3.65 PSI. So I just basically put a formula in here to convert outlink value to PSI, or something up here, PSI to outlink value. And two, if you're thinking in inches of mercury, you can look at the values over here if you're wondering about some of the scale. I would see I would see about I'd see that number 14 as a value on the vacuum side, so it's around 2 psi, and 2 psi is around 4 inches with mercury column. So there's just a quick little easy calculation helped me to make sense of the numbers while looking at it in Outlink. This page of the technical document explains how to scroll through the menus. It's a pretty good reference if you're setting it with the buttons. And then down below, it breaks out all the parameters that you're scrolling through. So all this will be available on the technical sheet I can send.